So good morning, everyone. Good morning, Vishal. Good morning, Anirudh. Good morning, Preeti. And today we continue from the part where we left off the last day. So, so before I do that, right? So let's get started with a quick revision of the stuff that we have done. And why is it that we are doing this? So basically, what I'm trying to do over here is I'm trying to lay out the foundation for developing the Basel models. Right? So we have been talking about. So basically, if you want to assess Basel models, if you want to understand Basel models, one of the basic criteria that we have, or one of the basic things that we need to understand, is the foundation on which this entire framework stands. That is the framework of model develop. So that is the framework of the asymptotic single risk frontier model, right? And in this respect, we want to understand that when we say it's an asymptotic single risk frontier model, what exactly is this model about? How is it that a probability is defined in that model? How is it or why is it that there are two different PD rating philosophies involved in this exercise? So how does that go about, right? So this is what we want to understand. And in order to understand this framework, right, we have started, what we did was we started by deriving the equation of the asset path from the Black-Scholes model equation. We explored different characteristics of that equation. So once we explored different characteristics of that equation, the next thing that we did was we used the Ito's lemma to derive the concept of the expression for the probability. Now, when we did that, we saw that the probability of a borrower to default is identified by the chances of the asset path going below the debt obligations. Now, once we have done that part, the next thing that we started talking about was also involving this part. So basically, what we started doing over here is we derive the equation for the probability to default, and we say that it's a normally distributed, it's a cumulative normal distribution. And over there we have bi minus log ai and all these. So we studied each of the factors. We saw that everything else remaining unchanged, if the debt obligation is higher, then the chances of the borrower to default is also higher. So this is precisely the reason as to why the greater the amount of loan extended out to a borrower, everything else remaining unchanged, is a more risky loan than than a lower amount of loan lent out to a different borrower. So therefore, the amount of the loan is one of the important distinguishing factor which impacts the probability of the borrower to default, right? Now, after that has happened, the next thing that we want to understand, the next thing that we want to study over here is the probability of the borrower. So, what are the other factors which impact the probability of the borrower to default? So, in that case, what we also get to see is that it is the initial amount of the asset or the initial asset path which is there, right? Now, when we go into this, one of the important things that we again get to see is the following: that when okay, so basically what we get to see is that if the initial asset of a borrower is higher, his chances to default is lower, which is pretty understandable, right? So if I have a huge initial asset, larger initial asset, I'm in a better position to take the loan because I have greater credibility. Therefore, it is negative. The probability to default is negatively related to the initial asset path. Now, it also may be the case that there are two borrowers who start off with the same initial assets, but one of the two borrowers, they grow at a faster rate, right? So when they grow at a faster rate, it is generally seen that so when it happens, when it grows at a faster rate, it is generally seen that that his assets increase over time at a faster rate, and therefore he becomes a better borrower. So his chances to default are lower, and higher the volatility is, right? Higher the volatility of the borrower is, the volatility in the asset is, lower are, higher are the chances of the borrower to default. So from there, one thing that we saw was that at the end of the day, right, it was the Wiener variable, the Wiener process, right, or the random variable, or the Brownian component, which had to play a very significant role in determining the behavior of the borrower, in determining the probability of the borrower to default. So if you have a look into this, you will see uh, that the probability to default is identified, or this CI that we are looking into, we're looking into the value of the Wiener process. So we are saying that if the Wiener process or the Wiener variable is below a certain value, the borrower is likely to default, right? Or the borrower would default. If the Wiener process or the Wiener variable is above a certain value, then the borrower is less likely to default. So this is where we see that we need to, there arises the need to concretize on, or to make the explanation more concrete for this Brownian component. So what we have just said is that there is a Brownian motion or the Brownian variable, but that is defined at a very theoretical level, right? Because the Black-Scholes modern model itself, based on which we have been deriving all these concepts, or the concept of the Brownian motion had come in, is itself a very theoretical concept. But now the question that comes out is, how do I adapt it to the banking model, right? So how do I define this Brownian motion? Now the Brownian motion, the Brownian variable is nothing but it is that variable which brings in the risk into the story, right? So we are, what we are essentially doing over here is we are bringing in the risk through the story, right? So over here, the Wiener process is, so the Wiener process we say is comprised of two parts in the real time. So how do I really interpret that? I say that the risk in the banking system or in the credit lending system can arise from two parts. One is your economy specific factors or sources of risk which impact the economy as a whole. That's one. And the second is the risks which are there due to the, the kind of risk because of the factors of the portfolio, because of the company specific factors. Say for example, let's take a case. Okay, say the 2008 financial crisis. So in the 2008 financial crisis, when the entire economy collapsed, the entire housing sector collapsed, so it impacted the economy throughout. So all the obligors or the involved in the lending process were affected by that. However, 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 there might, say for example, okay, just a moment. I think Anirudh has a question. Okay, okay, I'll just come to your question, Anirudh, back in a short while. Okay. Just let me finish this part and I'll come back. So over here, so basically, when in during the global financial crisis, when the entire housing sector collapsed, so all the firms involved in the housing sector was faced with the shock, right? So they were all exposed to the shock, and that was an economy wide phenomenon that had happened. So this was one kind of risk which impacted the credit. worthiness of the borrowers and hence the credit riskiness in the credit portfolios. On the other hand, there was a company specific risk. So out of that, some companies collapsed, some did not. Why? Because apart from the economy specific risk, there were certain other company specific risks which was going on. So the company specific risk is something which is more random in nature. Now the next part that we have over here is that, so therefore when I'm talking about the riskiness associated with the portfolios, right? So I'm talking about two kind of risk. One is a portfolio common factor and the other is a company specific factor. Now from here there are, now each of these factors have certain correlations, right? So for example, so there are two, three firms which are exposed to similar kind of risk, right? So that is, and each of them will have some kind of correlation with that economy specific risk. So that is precisely what we call the correlation coefficient for the portfolio common factor. The remaining is the association for the of the borrowers with the company specific factors. Now over here, so this is how we define the random or the Brownian motion variable. That there is a company specific factor and there is a portfolio common factor, a portfolio specific factor, and this WAT is, a sum of the two. So it is, the Brownian motion is a sum of the portfolio common factor plus the company specific factor. Right? Now over here, so this is how we define this Brownian motion. Now coming back, before I proceed on, right? So let's just talk about, just let me address Anirudh's question over here. So Anirudh, when I say that a loan of a higher duration is impacted by the riskiness, right? So what happens is, or it's more this. The idea over here is the intuition behind this is, suppose I give you a loan for 3 years, right, and I give you a loan for 5 years. Now, in the 5 years, the 5 year time period has a greater chance of your financial standards to fall. So, your financial standard to fall in the next 3 years has a probability. Your financial standards to fall in the next 5 years will also have a probability, but that probability will be much higher. So, in giving you a loan for 5 years, I am actually assessing your risk, or I am actually exposing myself to a larger volume of risk. Right? So that is why when T increases, now when T increases, your CI will actually go down. Right? So therefore, what we look to have over here is the following. Sorry, I mean when your T increases, your CI will actually go up. So over here, now coming back to the random the Brownian motion variable. Now when I say that there is a Brownian motion variable right over here, and I say that it's a sum of the two parts. One is a portfolio, so it's a sum of the portfolio common factors, and it is the sum of the company specific factors. Right, so it's sum of these two. So my Brownian motion is comprised of factors which is common, which impacts the portfolio as well as it impacts my company separately. So Y is a random variable which shows the portfolio common risk, and ZI are the random variables which shows the company specific risks. Right. Now over here, the first question that comes out to me is that what is this portfolio? How do I define this portfolio over here? Right. So now over here what we have is we have an asset path equation, we have a condition for probability to default, and now what we are trying to do is we are trying to understand that I have a portfolio, right? So what exactly is this portfolio? So there is, so basically simply defined, a portfolio is a collection of loans. So it's a collection of loans that are there in on my books. So if I say it's a credit card portfolio, what I simply mean is a collection of credit card loans. If I say personal loans portfolio, what I simply mean is a collection of personal loans, right? And what we assume for simplicity over here is that the exposure of the loans is equal in terms of dollars, right? Now, when I say it's equal in terms of dollars, it means you can as simple take it that everyone was given the same amount of loan and everyone was given a loan of $1, and the maturity of the loan is T. So most of the loans are maturing at a given time period T, right? So when I fix the maturity time period, what I am essentially thinking about is, okay, in the next T periods, what will be the probability of default? So that T is my performance account. So basically, what we need when we are developing the model, what we need to do is we need to identify those accounts which have a similar performance of 12 months. So basically, the T for us is mostly 12 months. PD is the probability of default, right? And we assume that each of the accounts have a probability Pi of defaulting. Now, what is my portfolio loss distribution? So basically what we are trying to do over here is we are trying to frame an understanding of the loss distribution, right? How is it that from this probability of default concept, from this framework, how is it we can design the loss distribution of the bank, right? So what is the loss distribution, or what I'm trying to assess is that, okay, I have given out K loans, N number of loans. What is the probability that some K number of loans will default, right? So say for example, I've given loans to 100 people. What is the probability that person 1 and person 2 and person 3 and person 4 करके and person 10 defaults? So what is the probability of getting 10 defaults out of 100, right? What is the probability of getting K number of loans out of K number of defaults out of N number of loans given? So that is the portfolio loss, right? And it is this probability that we are trying to estimate, because it is from this probability that we will. So once we reach to that probability expression, from there we'll be able to distinguish between the two major rating philosophies: the point in time PD and the through the cycle PD. Right. So from there we will be able to identify this portfolio loss, that what exactly is this PD and what exactly the difference between these two PDs, and how is it that we can start off with a particular account. Observe that over here we have started off with a particular account, right? We have said that there are n number of accounts, and now what we are trying to do is we are trying to find out the joint probability. So what we are trying to do is we are trying to aggregate that account level probability of default to a portfolio level. Now this is also what we do when, so this is exactly what we do when we are developing models, right? We have account level values and we are identifying the account level risks, and then we are aggregating it at the portfolio level. So what is it that allows us to do this? What is it that allows us to do a segmentation exercise? This is precisely what the idea is. So over here, before we move on, right, let's try to understand the basic concept of the joint probability of default, right? So before we move on, forget everything, whatever we have discussed previously. Just focus on the understanding of the portfolio description that we are doing, right? So try to understand that how is the portfolio being defined. Forget all the calculations or whatever theory we have talked about previously. Just try to understand the fact that I have given out, as a bank, I've given out some 100 loans, right? And I want to know what is the probability of k number of loans to exactly default, right? So this is what the idea is. So over here, we what we have done is we have defined the portfolio in terms of the number of loans. We have said that okay, the number of obligors in my portfolio is n. So I've given loans to some n number of borrowers. So just to simplify things, let's just concretize these concepts of n and k. So I say that okay, there are some n number of borrowers. So I've given loans to some 10 million borrowers, right? And what I want to know is that what is the probability that there would be like 0.1 million default. What how many will be there where there would be a probability of 0.2 million defaults, right? So similarly like this. So what I want to do is I want to understand what would be the loss distribution. So how is it that the different loss figures would vary over, so how would the probability of the losses vary over the increasing values? Right? What is the probability of getting loss less than equal to 0.1 million? What is the probability of getting loss less than equal to 0.2 million? Probability of getting loss less than equal to 3 million? And then we'll plot them and we'll get the loss distribution, right? And from this loss distribution, right? So this loss distribution also give us the distinction between the point in time estimate and the point in time PD rating philosophy and the through the cycle philosophy. So understanding the difference between these two probability of default is very primary, is very central before even we start thinking about developing a PD model, because your understanding of these two broad PD classes or these two PD rating philosophies will help you choose variables when you are developing a PD model, right? Great. So before we move into this, so observe what the question that we are trying to answer is this: what is the probability of getting k number of defaults of n loans? So if I were to give out n number of loans in the portfolio, so from there, what would be the chances of getting some n number of defaults? And to do this, what we look into is the joint, the concept of the joint probability distribution. So, what exactly is a joint probability distribution? So, we know that there are different kind of probability distributions, right? So, before we move in, let's just talk about this. So, we have discussed that what a probability distribution function. Say the most basic form of a probability distribution is where you have, it's a schedule, right? So you have the outcome x and you have the probability associated with the respective outcomes. x1, x2, xn. Now the probability, now x1 to xn are the outcomes which that variable can take. Say, for example, if I have a variable x, the variable will take the different outcomes like 2, 3, 4, 5, like this. And there would be always a probability associated with the respective outcomes, right? So the outcome probability of outcome x1 is p1, the outcome of x2 is p2, xn is p. So this is what the probability distribution is. Basically, so it is a schedule which will show or which will give us an idea about the outcome and the probability associated with the outcome. So basically, if I put it in a graph or in a graphical format, distribution would look something like this. There is x, there is px. And this is something like this. So when I plot the outcomes along with the probability, if x is a y while x is a continuous outcome, I'll get a curve like this. So this is a probability distribution graph. Your probability distribution. Probability distribution. Right. So now the next part that will come from here is what is a joint probability distribution? What is a joint probability distribution? Right? So what is a joint probability distribution? Suppose I want to understand that what is the probability that x1 and x2 would occur. What is the probability that x1 and x2 would occur if the variable x had realized values, right? So over here you see that I am not looking for probability only x1 or say less than equal to x2 or less than equal to x2. What I'm asking is a very specific question that what is the probability that x1 and x2 would occur? You see that what I'm trying to understand is what is their joint probability. of occurrence. The joint probability of occurrence. Basically, there is probably x1 and x2, right? So over here, what I'm trying to understand is that what exactly is the joint probability of occurrence, and this is and the distribution that we get by identifying, okay, what is the probability of x1 and x2 to occur, x1 x3, x1 x2 and x3 to occur, like this. So this is precisely what joint probability distribution is, which shows you that some set of events will occur together, right? So it does not show the probability of either a x1 or a x2 to occur, or x1 less than equal to x2 to occur. What it shows you that jointly a set of outcomes will occur, and this is precisely what the joint probability distribution is. Clear? Wonderful. So the next question that comes out over here is that okay. So the next question that comes out over here is that in our case, how do we bring in the concept, or why do we need a joint probability distribution? Why joint probability distribution to define the portfolio? So to define our portfolio, right, why is it we require the joint probability distribution? Now, why do I need joint probability distribution? I need it because I want to understand that what is the probability that there would be k number of defaults. So say k number of defaults, I say what is the probability that there would be uh, like zero point 0.1 million of the accounts will default. So what I want to know is what is the probability that the first account defaults and second account defaults and third account defaults and fourth account defaults and the fifth account defaults, like this for the first zero point 0.1 million account defaults, and then the remaining 9.9 million does not default. What is, or what is the probability that the first zero point 0.5 million, say 0.05 million account first default, then non-defaults, then 0.05 million account defaults again, then non-defaults. So there can be multiple ways in which these defaults may happen, right? So you cannot say that okay, only the first 100 accounts will default and the next not will default. So if 100 account defaults, right? So it means that there are some accounts, right? So these 100 can occur in any possible ways. right? What is the probability that 200 accounts will default? What is the probability that 50 accounts will default out of some 1 million account or 2 million account that has been given the loan to? So over here, what we need to understand is that what so how would that part look like? And this is where the joint probability distribution comes in. So what the joint probability distribution does over here for us is the following. It helps us estimate, find out the that probability that the first borrower defaults, probability that the second borrower defaults, like this, the kth borrower defaults. So what does this joint probability distribution tell me? So it tells me that what are the chances that the first k borrower defaults. Now if the first k borrower defaults, then like this up to the nth point. So this shows that, so this is what the joint probability distribution function is. So it shows that how easy, what exactly is the probability that there would be k number of defaults given in number of loans have been given. So for what is the probability that some k defaults can occur out of n defaults, and this is just only one pattern in which the k defaults can occur. And since it shows the joint probability of a joint occurrence, that a1t and a2 and a3 and a4 like this up to and ak defaults, and then k plus 1 and k plus 2 and k plus 3 and k plus 4 karke, and n does not default. So this shows a very specific joint occurrence of events, and this is where we require the joint probability distribution. So if you see this closely, we see that it describes the joint occurrence of events. A specific joint occurrence of. Okay, so over here, this B is nothing but your debt obligations. Okay, so this is your D. I had denoted it as D. This is the D. That is the debt obligation, right? So over here, what you will get to see is that the probability to default, so or the portfolio probability to default, will be what? The portfolio probability to default will be K by N. So this is your portfolio default rate. So observe that what we are trying to do is we have started from an account level feature, right? So the joint probability distribution is an account level feature, and we are trying to get to this portfolio level. Clear? So the point that comes out over here is that how do we do that? So what we have done is we have started on from an account level feature, and we are saying that the probability of K defaults to happen out of N. But what exactly is that probability? How do I know how many ways can that actually happen? Right? What exactly is this probability over here? Right? So to do this, what we need to do is we need to sum them up over all possible criteria. Now, so that means what we need is a mechanism which will help us aggregate these account level probabilities to the portfolio level probabilities. Right? Up to clear up to this point. Okay, Aniruddha, example regarding what? Okay, so suppose there are 10 accounts. There are n accounts. Right. And I want to know that what are the chances that there would be three defaults. So, so over here, you know your portfolio default rate will be zero point 0.3. That is 3 by 10. Right. Now, this 3 default can happen in any possible way. Say, accounts 1, 2, and 3 can default. Accounts 2, 3, 4 can default. Accounts 3, 4, 5 can default. Right. So in any possible way, this can happen. Right. Say it can happen three simultaneous defaults. It can happen alternate defaults. So basically, what we need to know is now we do not have an idea about the portfolio default rate, right? So think about the model implementation. How are we implementing the models? All we have today is a set of historic records, and I need to frame an idea about the loss that is going to happen in the next 12 months, the expected loss, and for that I need to have a portfolio level probability figure. So I need to aggregate up that probability figure that I have, or the loss estimate that I have. So all I have is a record of say 100 accounts today. Now I from this account level data, I need to frame an estimate for the credit card portfolio's probability of default. So every portfolio will have an average probability of default, right? I need to identify that what exactly that default is going to be. So what I do is I run my PD model for each account. I identify, okay, this is what the PD estimate is. And from that PD estimate, what I do is I do a weighted average. So I weight it by the average exposure and I compute a portfolio level PD for the credit card portfolio or for the personal loans portfolio. Now, what allows me to do that? So what I'm doing is I'm starting on from each of these accounts. So I say that there are 10 accounts, out of which there are 3 defaults. Now what I need to know is that what exactly is the probability of 3 accounts to default. It is not just 3 by 10, right? So that is the overall or the average probability. Now the 3 defaults can occur in any possible ways, right? So there would always be 3 defaults and 7 non-defaults. So what I want to understand is that given that there are 10 accounts, what are the total number of possible ways in which 3 defaults can occur? So that is precisely what my question will be, isn't it? So starting from the account level information, I'm trying to actually create out a portfolio level idea of the loss. So now this can only be done if it can be homogeneous or if it can be aggregated homogeneous. And that means there is some condition which is ensuring that this aggregation can be done. Right? Are you getting my point? Anirudh? Great. Now the next part that we need to ensure over here is that how do we compute this probability? Anirudh, Priti, any idea how this probability can be computed? Priti, Anirudh, this one, the account level. So how do I find out the probability of k number of accounts to default from n number of loans? Okay. Yes. Karan, you are absolutely correct. It's binomial distribution. Right. So what we are trying to do over here is we use the binomial distribution, right, guys? So over here, what we are trying to do is okay. So what we are trying to do over here is we have this. We are trying to understand that what are the chances that there would be k number of defaults, right, over n number of loans which has been given up. So therefore, if I want to find out that probability is nothing but the probability of that is nothing but the the binomial distribution probability. So that is my simple your binomial distribution. So there can be n ck number of ways in which these defaults can occur. So there can be c number of combinations drawn out from n, right? So over here, what we can do is so there are k number of nck number of possible ways in which this can actually arise. So what you can see over here is that 1t less than a2t a n t either than this. So what I'm doing over here is I am actually adding it over all the possible probabilities. So there is a possibility that say the first 10 borrowers default, the rest 90 doesn't. The first then there is a chance that the first five borrower defaults, last five borrower defaults. Then there's a chance that for one borrower default, second doesn't, third defaults, fourth doesn't. Like this, there can be n number possible ways, right? So what I will do is I need to add up all the probability value because given that probability is a continuous variable, we cannot do a summation. What we'll do is we'll add up all these probabilities over these nck occurrences, and this gives you your joint probability of loss. Also, now see that you can actually connect this equation that or this framework that you have over here. You can actually connect this framework that we have over here to the probability of default framework that we had created previously, right? So from the Ito's lemma and all that we had created that expression on probability, and over here we have this framework. So now you can see that that equation which was created, the probability of x1, you can actually put them over here, and from that point what you can do is you can very easily get this probability distribution in terms of that Brownian motion, right? So now you can see that now we can see that the equation from where we had started and the portfolio description where we went to, now these two are associated, and what we'll do is we'll pull those expressions out in over here, and when we come to this we see that we had connected the asset path, the probability the sources of riskiness together into one single framework. And from here, we get the condition as to why this aggregation from the account level data to the account level risk, how is it that you can actually take it up to the portfolio level, and that from there you'll get the idea as to why is it called the asymptotic single risk frontier model, right? So is up to this expression, is it clear? Then I'll move forward. Okay, so coming to your question, Anirudh. So Anirudh is a question for us over here, that here do we add up or will it be joint, that is multiplication? So obviously it will be multiplication, right? Because it's not, so there is always a correlation, they are associated with each other, right? They are not absolutely independent. Now if the borrowers or if the loans have been independent of each other, then it would have been a simple addition. Okay, so coming to in answering this, let's come down to the next question that Karan has. But isn't that binomial assumes that loans are independent? Yes, Karan, loans are independent. So the fact that you are taking the loan and I am taking the loan is independent. But we both are being given the loan basis our income, and our income is based on our employability. Now, if there is an increase in the unemployment in the economy, we may lose our jobs, right? So if there is a downturn, we both will lose our jobs, right? So though our loans were independent, we both are connected to the economic specific factor. So in that way, the riskiness of your loan and the riskiness of my loan is connected together, is correlated together by a common risk factor, that is the economy specific risk factor. So in that way, we do share a certain correlation with the economy specific risk, but all the trials of loans are independent. So if Anirudh is given a loan, if I am given a loan, and you are given a loan, we three are independent obligors in the books of the bank. But at the back end, all three of us are working people, which defines our affordability for the product. Right? So all of us get the same salary, say between 10 to 12 lakhs per annum. So we three are dependent on the economy, on the company that we are working. And as long as the company is working fine, we are there. But the moment the company stops or cuts down employees, right, there we lose our jobs. So if there is an economic downturn which affects the entire portfolio as a whole, we all lose out our jobs, right? So we may be taking three independent loans, but we are connected via the economic specific factors. So we do have a certain correlation with the economic risk specific factors, but the loans that we have taken are independent of each other. No. So over here, you need, so that is what the basic question over here, Karan, is that we are talking about three loans which are independent of each other. But these three borrowers have a certain correlation with a third factor, which is the economic factor. The economic factor is not impacting. So we all three are living in the state of an economy, living in the given state of an economy, right? Now you go to the bank, I go to the bank, Anirudh goes to the bank, we three take loans, right? Are these loans independent or dependent? Because the three loans are independent because you are not influencing my decision to take the loan. Anirudh is not influencing your decision to take the loan, and I am not influencing either of your decision to take the loans. Right? It doesn't mean that if the bank gives me loan, there is no guarantee that the bank will give you or Anirudh the loan. Right? The bank may very well give me the loan and not give you the loan. But the bank is basing its decision on affordability. When the bank is basing its decision on affordability, right, that is always attached to a third indirect factor, which is the economic specific factors, right? So the asset that I have
is not, I mean, is connected to the economy, and that is how we had defined the Brownian motion, right? That is why how we had defined the Wiener variable in the last session, that there is the probability of the borrower to default is connected or is impacted by the Wiener variable, which is the Brownian variable or the Brownian motion variable. And that Brownian motion variable is comprised of two parts. One is your economic specific factor, and the other is your company specific factors, right? So it is there that we are related with each other. If we were totally independent, so if we had three independent portfolios together, right? So we three were from, so there was no element of correlation, right? Then the loan process would have been random. So what we want to do over here is, or what we are trying to do over here is, we are trying to, so we say that okay, these are the three things that we have with us. So I have three borrowers who are coming up to me, and I am giving them loans basis their affordability as on the given state of the economy. But if the state of the economy changes, their behavior will change. But again, the impact that the economy has on the three of them would be different. So there is no dependence regarding that. It is just that there is a third indirect factor which is pulling in the three people together. So it might be the case that you, when the downturn comes in, I get a pay cut, but you lose the job. So so we have an impact. We'll have an impact of an economic downgrade, right? But that impact will also be independent for the three of us. But if the economy downgrades, we all three will be impacted. So in that way, we are connected to the economic movements, but the impact is independent on all the three of us. It is not necessarily that all three of us will lose the jobs. So that is why when we are writing this, we can obviously, the three loan trials, the three default outcomes. So if you default, Anirudh and I, all the three of us default, our three defaults are not connected with each other. Now we may be connected if there is a referral process. So you referred Anirudh, I referred you, and so that the three of us took the loans, right? So there the bank had a conditional distribution on, or a conditional impact on it. Clear? Excuse me. Okay, so now let's pull in back whatever we had done previously. Now over here, what I need to know is that, so from the previous calculation that we had done using Ito's lemma and stuff, what we did was the following: that what is the probability of default? The probability of default was this: AIT less than, this is what we had calculated, and when we did this calculation, our results showed that this was a function of probability that WAT less than CI. So where CI talks about, hold on, so it was a function of DI, that is the debt obligations that we had seen, right? So it was a function of the the initial asset value, or the part from where they had started off, the asset part starts off. There is a difference in the initial condition. Then it's like mu a minus half sigma square a into t whole divided by sigma a. There was a root t over here which I think I missed out the last time when I did the formula. So this is what how it looks like. Okay. Now over here, observe two things. So this is the WAT, right? Now let's think about it like this. Uh, Say that sigma I is equal to the right hand side of the equation that I. So what I'm saying over here is that sigma root t is positively related to the debt obligation. So if the debt obligations increase, CI will increase and the probability of default will also increase. It is negatively related to the initial log value, the initial asset value. That means when this increase, the CI will go down and the probability of default will also go down accordingly. So this shows the factors that are there, right? Now, now observe that. So what I can say over here is that this WAT is the Wiener variable, right? This is less than Ci root t. Right. Now observe that this figure that I have over here, right? This figure that I have over here. What is this W80? So this is the one that we had talked about, right? So this contains of two parts. One is your economic specific factor, which is your Y root rho, which shows the correlation of the firms with this economic specific factor, and then what you have is Zi root 1 minus rho. So over here, if I write this equation, right, what I can say is that Y root rho plus Zi root 1 minus rho minus Ci root t is less than 0. So the probability that AI is less than DI comes down to this particular part, right? So if you look into this set of calculation, so now over here, we are trying to estimate is that what is the probability of default is now driven by Y root rho, that is the economic specific factors plus the company specific factors minus Ci root t is that. So over here, so now try to track back and put this thing into order in your mind. So we had started off with the asset price part, right? From there we had solved for the equation for the asset part. We said that the probability of default will be nothing but the probability of the asset path to fall below the debt obligation. Now once this happens, this W80 is less than CI. Now when this CI is there, right? So given this CI, the next thing that we are trying to do is we see that the Wiener process is the variable which is driving the probability of defaults. Now, how is that Wiener process comprised of in the real banking world? So that comprises that's the part which gives the stochasticity of the riskiness in the portfolio. And what we have is Y root rho and Zi root 1 minus rho. So Y root rho is the economy specific risk and Zi is the company specific risk. So what I say is that the if the riskiness associated with it exceeds the CI, then we'll say that yes, there is a chance that this borrower has defaulted. Or you can also do one basic change over here, a small change in sign. That is, you have asset, right, and you have the liability, right? So this is a liability minus asset. So if the liability minus the asset is greater than 0, then Ci will be minus, right? So if you define it as a minus Ci, right, then what you will have is the following. You will have something like this. Minus. So this becomes your asset minus your liabilities. And this will appear as a plus. So this is just a conventional change of sign. However, it does not impact the real sense. So what it says is that the asset minus the liability, right, will be nothing but. So what is the probability that the sum of these three is less than zero? If the sum of these three is less than zero, then you know that there is a specific, so there is a challenge. Else you know that there is no challenge or default. So obviously borrowers who default must satisfy this particular characteristic, and borrowers who do not satisfy this condition are actually non-defaulters, right? So so this is how this, so now so over here, now when I define the portfolio, if I plug in this expression over here, right, you will see that the entire story, like these three separate components that we had obtained, one from the asset path we had obtained the probability of default. Then what we did was we talked about the Brownian motion, composition Brownian motion, and then we talked about the portfolio. Over here, we are bringing in all the three things. Now, the question that comes out is, how do I explain this? How do I interpret this particular thing? So, how can I interpret this? I can interpret this by the following criteria, that the probability of the borrower to default is driven by three factors. One is the economic specific risk, one is the company specific risk, and the third is the obligor specific factors, right? So CI captures all the obligor specific factor, that is the loan amount that has been taken, the asset that the borrower has, the asset growth, the performance of the borrower, and the volatility or the inconsistency in the behavior of the financial behavior of the borrower. So when I pull these three things together, we get the set of all the factors which impact or which may impact the borrower's risk. Right now, for example, if I now let's see that which we think should be the most applicable factors going forward, right? So I'll just put this part in. This is root row z1 root 1 minus row plus. So like this, finally end up with, So over here, now what you can see is that the portfolio risk is impacted by three sets of risks. One is the economic specific risk, one is the company or the individual specific risk, and the second is the obligor specific factors. Right? So the loan specific factors, the financial performance, and so on. So these are the three core factors which impacts your portfolio. Right? So this is what we have with us right now. Now the question that comes out from here is that out of this, which is that factor that would be used over here? So which is that factor, right? And over here, one thing that we can also see is that there is Z1, Z3, something like this. So, so how is it that we would, or what are the factors which would actually impact us in deriving the probability, the next probability of default, right? So if I have to compute the probability of default, which of these three factors will actually help me do that? Okay, so Karan has a question. Okay, so over here, I have two questions, one from Vishal and the other from Karan. I'll just take the two up and then I'll move forward. So over here, the first question that Vishal asks is that what is the last component of the equation? Just wanted to be sure. Is it only P? Okay, last component of the equation. Yeah, it's the row. It's not P, Vishal, it's row. Row shows the correlation of the borrowers with a specific risk. And coming to Karan's question, uh, finding out sigma of an asset, yes, Karan, finding out the sigma of an asset is possible because it is nothing but the volatility of the returns, right? So if I am a business house or if I am a firm who is actually operating, then what will happen is my asset part will grow over at a constant rate, but there will always be fluctuations, right? So some months I'll make more, some months I'll not make more, and so on. So that is what we are trying to talk about. Okay, so Vishal, yes, it's DP because fx dx, when we are integrating, it's minus into plus infinity fx dx. So it's DP over here. So to Karan's question, yes, the sigma can be calculated because that sigma shows the variation, right? So that is the volatility, right? So is this idea of the joint probability distribution clear? And is this equation clear to us? I mean, like, I mean, you need not, be very focused on the calculations. What you need to understand is the sense of the calculation. So are we clear on that? Oh yes, over here sigma A will be there. Missed it. Sigma A. Sorry. Thank you, Karan, for identifying that. Right. So over here for this one, your reference for this part will be uh, the Vasishek 1991, and the Vasishek 1997. So just type in Google Vasishek 1991 and 1997, you will get the entire paper. So what I've done is I've summarized the entire part. Right. Also, what I've done over here is I've just summarized the entire part, right? So it would not be possible for you to, it would not be very difficult for you to understand that. So, so my reference is Vasishek's 1991 and 97 paper. So this is a very critical part for understanding Basel, because it is this framework, which brings in the two concepts, the point in time period and the through the cycle period, right? So till now the discussion that we have had, we have identified that there are three core sets of risks, three core sets from where the riskiness is actually arising. So one is economy specific risk, the other is your portfolio specific risk, and the next part is your uh, and the next part is your obligor specific factors, right? Right. So this is what we have done till now. So we'll take a pause for the day, right? We'll not carry on with this further. Tomorrow we'll complete this part and we'll talk about PIT and TTCP, right? And in the meantime, download these two papers, Vasishek 1991 and Vasishek 1997. So understand the Vasishek framework, I repeat, is really important. And I'll mail you two papers which you need to go through. So these are two regulatory, the Basel regulatory papers. So there are two papers. I'll just forward the two papers to you before I close the session today. Just a minute. Hold on. Share the document. Okay, so one thing regarding this theoretical discussions that I am doing, right? So this was not a very, you know, established practice that I used to follow in my previous sessions. But of late, I happen to have given a few dummy interviews for practice modeling. Right? So while I myself was changing my job to UI or then looking out for other opportunities as well. So I saw that, mostly when clients are taking the interview, they now do not ask that typical question of can you develop a PD model or what are the steps of developing a PD model. So what has become now, with LinkedIn and with all these content websites and all analytics with them, also these steps of building the models have become very common knowledge these days, right? Now, how do they distinguish between a seasoned professional and a person who is just trying to like trying to join the domain by just studying internet materials. So what they are doing is they are now not asking you questions on PD, LGD, EAD models directly or at the first out. So they're not judging you basis that. What they are judging you is basis your knowledge of the regulations, about your understanding of the regulations, about your fundamentals of the regulations. And there was an interview which I had appeared for some times back in Feb. The interview was for Deloitte, I think. So they continuously for half an hour. So my interview went on for around 1 hour, 5-10 minutes, right? So out of that, for the first 35 to 40 minutes, they constantly kept on questioning me on the Basel document, nothing else. So different parts of document. How would you do this? How would you do that? What are the basics? So where does this result come from? How do you do that? So over the past few interviews, what I have noticed, right, also from feedback from my previous students, is that there has been a very sharp increase in questions from these theoretical backgrounds. That is why from this batch I have started laying stress so much on theory. But in my previous batches, if you see my previous recordings, you see I just taken up SAS codes, walked into the challenges. Now, once they are done with understanding that okay, this guy knows the regulations, the next question they start giving out is on the challenges that you face while you do this data exploration, doing that and all. Then they ask you separately questions on logistic regression, linear regression, etc., etc. So they do not ask you these templated questions of developing how to develop PD model or develop an LGD model. So the high-paying jobs or the high-paying openings which come up, they are increasingly laying stress on the the documents, the regulations as such. And hence, what I have done is I have introduced this impact of the theorization in this module. Yeah, was somebody saying something? I missed out. I'm sorry. Yes, concepts basically. So they want to understand that how well do you know the regulation that you have worked on, right? So like bluffing is becoming more and more difficult because with an increase in these regulations and more regulations are coming up, right? So there's a lot of work which is going around in CCAR and DFAST. So they don't ask you how do you validate a CCAR model. They first ask you what CCAR is and they see whether you know the basic nuances of CCAR. They'll ask you that first. Now, once you are done with that, the next thing then they go into ask you is, okay, then tell me what is this time series model? How will this time series model work? What are the challenges, EAO, etc., etc. So, so that is how they have kind of started restructuring their uh, questions. Okay, so this part will do for the time. And please download. Karan, as far as regulations are concerned, right, you have to read the regulations. There is no other alternative, right? So, no, so you need not study Basel 1, you just need to know the basics of Basel 1, but your in detailed study should begin from Basel 2 and then go on to Basel 3. Right, so I generally stress, I know that it's very difficult reading these regulations and all, but nothing can be done, right? You have to have a detailed understanding of Basel. So this is an error which I have also made previously, in my initial sessions, the way where I used to tell them that okay, give them an overview of Basel and go in, but when they go on to interviews, the interviewers, they just drill into that, because especially what happens is most of the people who come in for this model, they are experienced. They may not have experience in Basel, but they do have experience somewhere, right? And now when people, and one big challenge with the banks is that they cannot hire these people at a business analyst level, because that's a very junior profile. So they have to have them somewhere at an assistant manager level or something, where it is very important that the person has a good understanding of of the regulations, as well as of the functionality. The functional and the technicalities can be taken care of, but the knowledge of regulations is something which has to be developed, right? And now this is something where I had very recently given appeared for an interview with this bank, Bolo HDFC, right? And they just drilled me into Basel. They just literally drilled me, right? And talking about portfolios, what are the different type of exposures? Five different exposures. So out of these, how many exposures have you worked on? What? How do you define a retail exposure? What is it? How is a commercial? How is an SME different from a commercial? What is haircut? What is standardized approach? What are the new changes that have been proposed under Basel 3? How is the EAD model development technique changed from Basel 2 to Basel 3? So they just directly go into this avenue. They don't ask you what is EAD model development. Now the reason is they know that they have their own templated process. They'll give you three model documents. You'll go through that. You'll understand how it is done. They want to know whether you have a clear idea about the things that you are going to work on. How clear is your idea? They ask you questions like what are the different kind of segmentations that the regulatory segments that is required for developing the retail Basel model, right? What are the important checks that you need to do while at a model design stage? So how would you develop a Basel compliant PD model? So they always link it to the regulations, and that is why I am going to the regulations from this basics, right? So just hold your patience. I'll come to SAS. I'll talk about model development and all. But what I want is that you must have a foolproof interview preparation. So I know that it might take much more time than perhaps been given in the model in the brochure, right? But I want to ensure that every aspect is covered, right? Including IFRS 9. So when you go out there and you are appearing for the interview, should be able to nail it at any cost. So that is what I'm trying to do over here. I don't want to leave any open ends. So just hold your patience, go through the documents, try to think about what has been done in class, and try to recollect it over uh, the time, right? Try to construct things at your own end, and then over a long period of time, then read books, read more of papers, go through Basel videos, go to BIS website. There are a lot of videos, there are a lot of documents over there. Read through them, because the only way to learn Basel is to read Basel, right? So do this, Give in your best. Take this entire year, take up to December, prepare yourself. Next June, Jan onwards, go for it because Basel 3 will, the people will start implementing Basel 3 from next year or next year onwards, right? Uh, and its deadline is 2022. So there would be a dearth of it coming in very soon. So prepare yourself, get your foundations very clear. That's all that is needed, right? Any queries, anything, just reach out to me. Give me a buzz on my mobile or WhatsApp me like Anirudh does, because since I have office from Monday to Friday, I do not get time to check my daily emails with my TextLab ID mails. Okay, so because I'm like, since I'm into the consulting profile, there's a lot of traveling involved. There is a lot of work and a lot of people management role, and also I don't really get time to check my mails regularly. So just reach out to me directly. Just reach out to me. I think we already have a WhatsApp group, right? Okay, no, it might be that Vishal Karan and Akash is not added to the group. So okay, I have. Karan, can you give me your number? Or do one thing, guys. Just ping me on this number. This is my number. I'll add you all to the group. So this is my number. Just add me to the group, right? Give me a buzz. Give me like ask me directly whatever you want, whatever requirements you have, anything, right? Because going to the mail becomes previously what used to happen is when I was full time at TechLab, I used to check my mails regularly. But now I hardly do check the mails at the late night or while I go to office. I might check or I may not check. I might forget. So just give me a buzz directly or just WhatsApp. So this is what something Anirudh does, and it becomes very easy for me to reply back to him immediately. So do that practice, right? And I believe over our next couple of months we should be in a good position to appear and go for interviews and all. Yes, I got. I think this is Karan, right? 9780. Great, great, Karan. Thank you. I'll just get back. Thank you, guys. Thank you. Have a great day, and let's catch up tomorrow. Bye bye. Thank you, Bishop. Bye bye.